Recording now, and we'll go ahead and do a couple of things. First of all, let's go ahead and review. I want to make sure y'all look at your notes. I think we went over NPX last time, but I need y'all to verify that.
Yes, sir.
Okay, and we talked about the symbols, and I told you that you need to make sure that you use a number line whenever you're dealing with the NPX, because when you're dealing with NPX, you also have to deal with the number line, basically because the number line, if you have 0, 1, 2, 3, 4, 5, 6, 7, 8. If your set is from 0 to 8, it's supposed to be, oh, there we go. From 0 to 8, and I ask you, what is the probability, and you've got 10 households, and you have a probability of 0.6, then what is the probability of exactly 3? Exactly 3 would be just that point right there, and you'd put a 3 right here, and then you would use second bars. I think it's binomial PDF. Y'all check my notes. Binomial PDF. And the PDF, the P stands for exact. Okay? So if you want exactly a number, then you use the binomial PDF and you type in NPX. If it is one of the inequalities, if it's a at most 3, if I give you at most 3, then that means it's the highest number, which means I want all 3 of these, and that means I've got to do NP0, NP1, NP2, and NP3 based on this N and this P, and then add all those together, or I can do second bars binomial what? Anybody got it written down in their notes? Binomial CDF, and what does the C stand for? Cumulative, meaning that if you type in NP3 on binomial CDF, it's going to do everything to the left of 3 down to 0. And that's what you use the CDF for. And then if I ask you to do, at least 4, what does at least 4 mean? That means the lowest number is what?
4.
4, and I need all of this. Well, I could do NP4 plus NP5 plus NP6 plus NP7 plus NP8, or I could do 1 minus the probability of at most 3. Okay, we went over this, right? Make sure. So those are the 3 type problems you will have with NPX. We went over those, right?
Yes.
Okay. Now, just to recap, now there's a little bit of lag in my presentation versus my voice, so I'm sorry about that. There's nothing I can do about that. I'm just glad that I'm able to do this. just to go over a little bit, 6.1 so far has been probability distribution, being able to find the mean and the standard deviation. Okay, we did that first couple of days of 6.1. And then a binomial distribution, which means NPX. Okay, so those are the two types of problems that we've gone over so far. Okay, now let's get back to sometimes I have to find my mouse because I've got a white background on my laptop. Let me make this small. And that's where we're at right there. And of course, we went through the three problems. That is exactly 5 cars. So that would be, I don't have a calculator with me. And the reason I don't have one on my computer, this is my home computer. And I'm able to hook everything up to my home computer. If I use my Tri-County computer, I can't hook up with one thing, and that would be the document cam. So it's either use my home computer and not hook up all this stuff that I've got hooked up and be able to use the calculator on the computer, or be able to hook all this stuff up and not be able to use the calculator. So I chose not to use the calculator. So I'm going to have to find one somewhere that I can use under my document cam because I don't have one on my home computer. Anyway, so you would type in second bars, binomial PDF, and you would type in N is equal to 20, P is equal to 30.35, and X is equal to 5. And then, of course, this is less than or equal to 3, so that would be, as we just said, 3 or less. So that would be, you could do that, or you could do binomial CDF of NP3, NP3. So that would be 20.35 and 3. And it should give you that 0.044. And this is the complement, what we were just talking about, and that's that. Now, what happens after that? Well, then you've got this. Write this down. This is the mean and the standard deviation of a binomial random variable. Okay? So let's go back to my handy dandy drawing, I meant my Word document cam. And so here with a probability distribution is the event and the probability of the event. Remember 0, 1, 2, 3, 0.1, 0.3, 0.3. Let's see, that's 6, 7, and this would be 0.3. And then you find the mean and the standard deviation of that. Okay? Now we're going to find the mean and the standard deviation of this binomial distribution. Mean and standard deviation of NPX. Okay? So that's what we're doing now. So this is like 6.2. I'm just trying to keep this separate because I don't want you to get bogged down with a bunch of, what do I need to do here and what do I need to do here. All right, here is the formulas for those two. There's the mean, NP, and there's the standard deviation, NPQ. Now remember, I don't use 1 minus P. I use Q. Because Q is the what of P? Somebody tell me. Starts with a C. Y'all just not going to talk to me?
Complement.
Complement, thank you. Okay? So I don't use 1 minus P. I don't use that. I use Q. So sometimes you may see mean is equal to NP and standard deviation is equal, and variance is equal to NPQ and the square root of NPQ. All right, so I'm going to go back here, and I don't mean to go back and forth, but I'm doing it for a reason. I should just show you this and just put the screen, but I don't have enough room to do that. See, I don't have enough room, so I can't do that, so I have to switch back and forth. So with, I'll make it bigger, there we go. With the mean and standard deviation, the mean is equal to NP, and the variance is equal to NPQ. And what's the relationship between the variance and the standard deviation? The standard deviation is the square root of the variance, okay, which is the square root of NPQ. So I just want you to realize that sometimes you might see Q instead of 1 minus P. In fact, most of the time you see Q instead of 1 minus P. So these are some simple problems, okay? You don't have to do, you can do the NPX on your calculator, which is finding the probability. And this is finding, let me write that down because some people don't know, probability of X. What you're finding here is the probability of X there, okay? And this is finding the mean and the standard deviation. I just want to use different colors, that's why I'm doing that. All right, so with that being said, let's go back to the slideshow and give y'all a chance to write that down, NP and NPQ. My cats are fighting. And here is an example. So I want you to write this example down because this is a type of problem. And what is the difference? The difference is, what does the direction say? Finding the mean and the standard deviation. The directions are going to tell you what to do. Okay? If you don't read the directions, then you're not going to know what to do. According to the blah, 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 35% of all car-owning households have 3 or more cars in a random sample of 400. Determine the mean and the standard deviation. Well, what is N? N is always your what? Biggest number. So which one is your biggest number? 400. And P is always your percentage. So there is your mean. And then, of course, NPQ. So I want you to write this question down and write those answers down because that is how you do the mean and the standard deviation of a NPX problem. The reason I say NPX problem is I try to get you to differentiate between the probability distribution and a NPX problem. Any questions on that problem? Okay. I'm going to give you just, let me know, do y'all have that written down?
No, I need another minute.
Okay. Squeaky door gets grease. Gotta tell me.
Okay, I got it.
Okay, everybody got it? All right. Now it says graph the binomial probability distribution with n is equal to 8 and p is equal to 0.15. Graph the binomial probability with n is equal to 8 and 0.5. And graph the binomial probability distribution with n is equal to 8. I don't know why they want you to graph it, but you take 8 times 0.15, 8 times 0.5, and 8 times 0.85. And I don't know why they want you to graph it. There it is. I don't know, again, I don't know why they want you to graph it, but there it is. That's not a test question. I don't even think it's a homework question, but I can't do much with that one. So I'm just gonna, I want you to find the mean and the probability distribution. So if n is equal to 8 and p is equal to 0.15, q is equal to 0.85. And then you can find the mean and the standard deviation. Okay? There's that. And what they're doing is they're graphing it with 1, 2, 3, 4, 5, 6, 7, and 8. And I don't care about you graphing it. And there we go. Then we're going to get into some graphing, and I'm not going to worry too much about that. Graph the binomial probability distribution with n is equal to 25 and p is equal to 0.8. All I care about is you being able to find the mean and the standard deviation. So the mean would be 25 times 0.8, which would be what? 2.5 times 8, which is 16.5. I'm thinking, let's see, 8 times B4, be 20, won't it? Somebody multiply 25 by 0.8. What do you get?
20.
Okay. And now I want to do NPQ. Well, NPQ will be 20 times 0.2, which 20 times 0.2 will be 4. And the square root of 4 is 2. So if you did NPQ, somebody take NPQ and take the square root of it and tell me if you don't get 2. (25 times 0.8 times 0.2), and then multiply, and then raise it to, or take the square root of it.
It's 2.
Okay, so here the probability of it, the mean is 20, and the standard deviation is 2. That's what I care about. This one says graph the probability distribution with n is equal to 25 and p is equal to 0.8. And there it is. We see that it's pretty much skewed left, meaning that all the data is on the right. Why are they so into graphing? I don't understand why they're into graphing. I'll have to figure out how to graph that on the calculator. I'll have to find that out for Wednesday or Thursday. Okay. I'm not going to worry about this graphing. Okay, for a fixed p, a number of trials and a binomial increases the probability distribution, blah, blah, blah. As a rule of thumb, write this down. This is important. If NPQ is greater than or equal to 10, the probability distribution will be approximately what? Bell-shaped. That means it'll be pretty much a curve. So as a rule of thumb, if NPQ is greater than or equal to 10, then the probability distribution will approximately be bell-shaped. Okay? That's something you might want to write down. Use the empirical rule. There's the empirical rule that we learned back in Unit 1 to identify unusual observations in the binomial experiment. The empirical rule states that in a bell-shaped distribution, 95% fall between two standard deviations. So write down empirical rule. You're going to need to know that. Okay, there's the 5% rule. Remember me telling you that anything above or below a nickel, if it's above a nickel, then it basically is normal. If it's below a nickel, then it is unusual. Okay, so there's the nickel rule. So you might want to write that down. If it's above a nickel, it's normal. If it's below a nickel, it's unusual. Okay, there's our, according to the Experian, 35% of all cards. Let's write this down because this is, I don't know. I'm looking to see. Okay, we did the first part. 35% of 400 is 140, and MPQ is, or square root is 9.54. Then he conducts a random sample of 400 cars owning households and found that 162 had 3 or more cars. Is this result unusual? Well, you would draw this out. Remember the curve. I'm going to use 10. Everybody understand? I'm going to use 10 as a standard deviation. Y'all get that? So 140 and 10. So I'm going to take my handy dandy sheet of paper, and we're going to go back to Unit 1. $140 is in the middle, $150, $160, $170. $140 minus 10 is $130, $120, $110. 0.15, 2.35, 13.5, 34, 34. How much of a lag is there in my drawing? 13.5.
It's pretty bad.
Is it bad?
Yeah, to me it is.
Like a couple of seconds or a minute or what? Maybe a second or two. Okay. And we know that 2 standard deviations, 1 plus 1 standard deviation plus 2 standard deviations, -1, -2. We know that this area is what? Uh-oh, Miss Watt left. Let's see if I can call her back in. What was her first name? Karina. There she is. She came back. What happened, Miss Watt? Did you get kicked out?
It said the call was reconnecting.
Oh, well. Okay. Did it ask you to come back, or did I get you back? I'm not doing anything. I think that's her internet. So is it a 1 or a 2 second delay? Or 3 second? Y'all ain't gonna. Okay. So, and there's your nickel. Where's your nickel? Well, what's 2.5 and 2.5? What's 2.5 plus 2.5? 5, Hubert. That's right, class. So that's your nickel rule. So if it's less than a nickel, it's unusual. If it's more than a nickel, it kicks into the green. So you've got to remember this empirical rule. That's why I showed y'all the empirical rule the first unit, because the empirical rule is used all throughout the semester. And what was the question? 160 what? Was it 164? Are y'all with me? I hope I haven't lost y'all. Have I lost y'all too?
No,
I'm here.
Okay. Well, what kind of a delay do I have? 1 or 2 seconds?
I mean, it's a few seconds.
It's a few seconds? Okay. Well,
I'd say about 10 to 15.
oh my gosh.
If
Well,
not
yesterday in the morning it was 10 to 15, they said, and then in the middle of the day it got better. So I don't know. I'm sorry, it's such a bad delay. Miss White, I'm sorry you're going in and out. There she goes out again. It must be something to do with her. I hate that. And see, she was fine until all of a sudden it started getting kicked out. So I don't know what's going on. All right, but anyway, the 164, where does the 164 land? I'm asking y'all to answer that. Where does the 164 land?
In 2 standard deviations.
Can y'all see where the 164 is on my chart?
Yes.
Okay, does it land in the normal or the unusual?
The unusual.
So then it's unusual. 164 would be unusual. So let's go back to the question. Hold on a second. I'm trying to get to I'm having to switch screens here. There we go. So they say 162. I'm sorry. 162 would be unusual also. So let's go back to and there we go. And they're doing it like this. And the result is 162 is greater than 159. And they're doing it without the graph. Okay? They're saying what is mean minus 2 standard deviations? 120. That's what we had. We had 120 on one end and 160 on the other end. I didn't use the decimal. Remember, I just used 10. Okay? And 162 is outside the normal area. Okay? They're doing the same thing that I did with there. See, there's the 159, 159.9, I think, is 160, and 120.9 or 119.9 or whatever is right there. And ours, 164, 162 is right here, and that lies in the unusual area. It's better when you do the curve. If I showed you this without showing you the curve, you'd be like, well, what the heck is this? Okay? That's why that curve is so important. Everybody got it?
Yes.
Okay. Gotta get some kind of affirmation that y'all up with me with the 10-second delay. Oh, and that's 6.2. Let me get out of 6.2 and let's go to 7. Now remember, you only got 4 sections on this test. 6.1, 6.2, 7.1, and 7.2. and it's going to be pretty much divvied up 25% each material. So 25% per section. I'm telling you what you'll have, and this is the area under a curve. So let's go ahead and hit slideshow. Area under a curve. I don't need to show you that. Don't need to show you that. Probability distribution. Okay, write that down. The probability density function, PDF. It's going to be called normal PDF in your calculator. Write that down. Normal PDF. Normal distribution slash PDF is an equation used to compute probabilities of continuous random variable, blah, 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 area under the curve. That's basically what you're finding. Total area under the graph, area under the curve. So all you need to write down is normal distribution PDF is area under the curve. Normal PDF is area under the curve. Now, this is called uniform distribution. Okay? Now, I'm going to show you this on the, I can't do this on the slide. I'm sorry. I'm going to do this on the, here we go. All right. Is the delay only with the drawing, or is the delay as bad with the PowerPoints?
It's both.
Both. I wish I could do something about that, but I can't. All right. A normal, remember, a normal looks like this. Uniform looks like this. So this is a normal distribution, and this is uniform. Now you will have a couple of questions on the test from uniform. The rest of them will be normal. Okay? All of the questions in chapter 7 are going to be about these two curves. Well, one of them's not a curve, one of them's a box. Okay? Can anybody guess what uniform has to deal with? Can anybody guess why does it look like a box? It looks like a box because it's uniform, because we can't control it. Does anybody know one thing that we can't control? What's the one thing in life that we cannot control? Starts with a T.
Time.
Time. We cannot control time. So therefore, it does whatever it wants to. And that means that it does a straight line like that because there's no variation in time. Can you make time speed up? No. Can you make time slow down? No. Can you manipulate time? No. You cannot do anything to time. Time is the only thing that we cannot control. So that's why it has a uniform distribution. Now, how do you use the uniform distribution? Well, first of all, the area under the curve is always going to be 1. Now, I use 4 digits because anything 4 digits is area. Write that down. 4 digits is area. So if you see 0.2134, you know that's an area. If you see 0.4268, you know that's an area. If you see 0.5132, you know that's an area. If you see 0.9681, you know that's an area. Anytime in this chapter you see 4 digits, 4 decimal points, you know that's an area. 2 digits is z-scores. Okay? but we're not going to worry about z-score right yet because we're in uniform. So the area under this curve is 1. Let's say that a stats class lasts 50 minutes. What is the probability that your teacher will shut off class after 45 minutes? Okay? So what do? Well, the bottom of this curve, rectangle now is 50. 0 to 50. Because this is minutes. Now, the area under a rectangle is equal to what? Length times what? Length times width, or base times height, or base times height. Okay, we know that the base is 50, we know the area is 1. So what is the height? Divide by 50. Divide by 50. So the height is equal to 1 over 50. So this height is equal to 1 over 50. Okay, so I just found out what the height and the base of this rectangle is based on what I was given in the question. Stats class lasts 50 minutes. What is the probability that your teacher will go past 45 minutes? So I find 45. I need to find the area under the curve at 45. So I need to find this area right here. So what is the width of that orange area? Somebody tell me. I want y'all to tell me. I don't want y'all to be quiet. What's the width of the orange rectangle? You know the height is 1 over 50. What's the width? What's 50 minus 45? 5. So what is the area of the orange box? The area probability of 45 is going to be equal to 1 over 50 times 5 over 1, which is equal to 5 over 50, which is equal to what? So you've got a 10% chance, or 0.10, okay, 0.1% chance that the class will last over 45 minutes. Which means you got a 90% chance that the class will last at least 45 minutes. Do you understand that? So if this is 0.1, what's this over here? What's this big area over here? I'll color it in pink. No, that's not pink. That's red. I don't like red. I don't like that color either. Hold on a second. We use peach. If this red area is 0.1, then what is this area to the left of 0.1? 0.9000. So what kind of a chance is it that your teacher is going to go above at least 45 minutes? Well, that's going to be like 90% chance. And this is a 10% chance. That's how you do uniform curve. Am I still writing? Am I still writing for the delay?
Yes.
Well, I'm sorry. Maybe I just need to talk slower. I'm sorry. I don't understand why everything's so slow in the morning. Maybe the internet has to have coffee too. So here's the problem right here. Write this one down. This one says the graph below illustrates the properties for the time example. Notice the area of the rectangle, blah, blah, blah. This time, this class goes from 0 to 60. So the base of this rectangle is 60. The area inside the rectangle is 1.000. So the height is going to be 1 over 60. Now that's what I just showed you using area equals length times width or base times height. So what is 60 times 1/60th? 1. So your area is 1. Okay, so that's really not a difficult, they're going to give you that. You used to have to calculate that, but now they're making the questions to where they give you the 1 over 60th. So it's not a big deal now. And now they're going to ask you, what if? So let's click on the next slide. And okay, they're telling you blah, blah, blah. Area of the graph, blah, blah, blah. Okay, there we go. What is the probability that the time will fall between 15 and 30 minutes? So write this down because you've already wrote down the rectangle with 1 over 60. Write this down right here because this is a question they're going to ask you. The probability of choosing a time that is between 15 and 30 minutes. So 15 and 30, you want the area of that blue rectangle. So what is 15 from 30? I'm asking y'all, what is 15 from 30? It's 15, Hubert. Thank you, class. So 15 is the width of that rectangle. So 15 times 1 over 60 is 15 over 60, which is 0.25. So the probability that something is going to happen in between 15 and 30 minutes is 0.25, 25%. And that is how you do a uniform distribution. You're only talking about 2 problems on the test, because I don't test you much on uniform distribution. But it's pretty simple if you just remember the area of a rectangle. If you remember the area of a rectangle, then this shouldn't be that big a deal. And you got to remember that 1 is the area of that big rectangle. Okay, between 0 and 60. Everybody understand?
Yes.
I don't know what y'all see. I wish I knew what y'all see. There's no way I can see because I don't see the delay that y'all see. Okay, this is a bell curve. Now they're fixing to move into the bell curve. The bell curve has a area of 1.0000. Okay. Now we're going to use z-scores on the first part of chapter 7. Okay, I really don't care about this. Normally distributed. Remember, we're going to use normal PDF with this. And I'm not really worried about this either. I'm not worried about that. Y'all know about the empirical rule. There's the empirical rule. I'm not wanting to do that. I'm not wanting to do that. I'm not wanting to do that. Just give me a second. Okay. In the next slide, we have a normal density curve drawn over the histogram that they just came up with. They want to know the height between 34 and 35 inches relate to the height under the curve. Between 34 and 35 inches. See, there's no way to tell because your empirical rule only gives you the blocks of 34, 34, 13.5, 13.5. You know, they only in those blocks. What if you get something that's in between those blocks? Well, you guesstimate or you use z-scores. And I'm trying to get to the z-scores. Okay. This is not. Are we ever going to get to the z-scores? Hold on a second. I'm going to try to get to the z-scores because you can't do this without z-scores. There. Okay, so write down your formula for z-score, which is z is equal to x minus mu over standard deviation, or x minus x bar over s. Now, when you're using the z-score, your mean for your drawing your curve is going to be 0 and the standard deviation of 1. So this remember me telling y'all a long time ago to go to Google and type in normal curve with z-scores and put it on the word processor and print out like 10 copies? This is where you're going to be drawing the curve over and over and over and over. So you might want to use those, okay? Now, let me see the question they're going to give us. It's going to look like this right here, only it needs to be filled out. I would have the empirical rule on there, and I'd have 0, 1, 2, 3, and the percentages, yeah, but not just blank like that. Okay. All right. IQ scores can be modeled by normal distribution, blah, blah, blah. So you can turn anything into a z-score. So write this question down. It says IQ scores can be modeled by normal distribution with mu is equal to 100 and standard deviation is equal to 15. What does it mean when you see mean and standard deviation? Draw the what? Draw the curve. So when you see mean 100 and 0 or standard deviation is 15, draw the curve because they're going to ask you something about that curve. Now, not right now, but they're going to ask you more about the curve here in just a few minutes. We're fixing to get into it. All right, so 120 minus 100 is over 15. There is your z-score. Now that is what you're going to put into your calculator when you use normal PDF. Unless you got a newer calculator that changes it for you. So I'm going to go to I'm going to leave this up because I need to. And I'm going to pull this over here. And I'm going to make it smaller. Now, if I make it smaller, tell me if the delay is longer or shorter. Is that fair? So, here we go. We've got a mean of 100 and a standard deviation of 15. Mean is equal to 100 and standard deviation is equal to 15. Is the delay longer or shorter, or does it make any difference?
It doesn't make a difference on my side.
It doesn't?
I don't think it makes a difference. It's still just as long.
I'm sorry. Okay, so when you see this, draw the curve. $100, $115, $130, $145, $85, $70, and $55, I think. Now, it also helps. That's why you need to find a curve on Google that has everything. Put the z-scores down here, 0, 1, 2, 3, -1, -2, -3, and then put the empirical rule, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Now, if you want to draw you now of course you can't predict what the mean and the standard deviation is, okay? That's not going to be on there, okay? You have to fill that in. But the 0, 1, 2, 3, -1, -2, -3, and the empirical rule, you can draw you a nice curve and run you 10 or 20 copies of it, and that way you want to draw it over and over and over and over. Okay? I usually tell 30 students that. One student usually does it. And the other 29 bitch and moan and complain about having to draw the curve over and over and over. So don't be one of those that whine. All right. So anyway, this is what the curve should look like when you start this problem. Now, we're going to calculate x z-score is equal to x minus x bar over standard deviation. So that's going to equal, and I think they say 120. So 120 minus 100 over 5, or I'm sorry, standard deviation is what? 15. So that's going to be z is equal to 20 over 15, and I think they said that's 1.33. So 1.33, I'm going to put it in green. 1.33 is going to be somewhere in here. Everybody agree with that? Now, you could actually take, this is 50%. 50 plus 84 is, 34 is 84, and then maybe not half of this, but maybe a third. 3 will go into 15.5, so I'm going to say it's 5%. So 84 plus 5, I'm going to say that this area right here is around 0.8900 using the empirical rule. Now, when I use the empirical rule, I'm guessing, but it's enough of a guess to let you know that you're either right or wrong when you do your math. Over here would be 0.1100, I think, which is the complement of. So you got 0.1100 on the right, you got 0.8900 on the left, and that's by the empirical rule. Now, how do you find that area? Well, you use your calculator. Now you can use the tables, but I don't use them anymore because they're obsolete. So this arrowhead down here is negative infinity. This arrowhead right here is called positive infinity. We can't type in infinity, so we're going to use negative 9999. Okay? And we're going to use positive 9999. Which way do we read? We read from left to right, Hubert. So we need this area from negative 9999 to 1.33. So I take my handy dandy calculator. I need y'all to do this. Y'all got y'all's calculator with y'all?
I don't. Mine's in my car.
Okay. Do you have yours, Miss Holcomb? She might be getting it. Well, this is what you would do. You would do second vars normal PDF parentheses negative 9999 comma 1.33. Miss Holcomb, do you have a calculator? She must have went back to sleep. Okay. And that's how you find this area.
I've been answering you the whole time, but I've been on mute.
I'm sorry, what?
I was answering you when you said my name, but I didn't take it off mute.
Oh. Okay. Do you have a calculator?
Yeah, I'm using one that's on my phone.
You don't. Do you have TI?
I do.
Okay. Type in second vars, and then which number is normal PDF? I think it's at the very top.
1.
1. Good.
1.
Number 1. Okay. Now, what does the screen ask? Does it ask you the mean and the standard deviation, or does it just say parentheses?
Well, it's not working for me.
When you hit normal PDF, what does it ask for? Does it?
Hold on.
Okay. Wait a minute, I think I got one on my phone. I don't know if I've ever downloaded it. Let me see if I've downloaded it.
Well, that one's not working, so the one on my phone, so I'm grabbing my other one.
Well, hold on, I'm going to look for mine too. I think I have. I forgot about my phone. Well, I'd like to find it. I know I've got it. Let me just look it up. It's Wabbit EMU, W-A-B-B-I-T, Wabbit EMU. There it is. I'm going to do the TI-84 Plus. Okay, it said it may take a while. Did you punch it in, Miss Holcomb?
I did. I got 0.
No, it's going to be around 0.89, 0.9. Did you type in negative 9999, comma 1.33? everybody just left.
Hi there. It's currently 9:05 a.m.
Well, everybody left. Miss Adams, are you still there? Miss Holcomb, are you still there?
I'm here.
Okay, Miss Holcomb, what happened? Okay, let's go ahead and call it a day. I don't know why everybody's going in and out. So I'll go ahead and shut off the recorder, and we'll take this up at the next class, and we'll work on the calculator if I can find a calculator to pull up. Miss Holcomb, I'm going to go ahead and stop the class.